Hello and welcome. This is my number 8 broadcast of a series of broadcasts that I'm also archiving in a journey to reinvent the wheel and make a web server in C++. And already we have a viewer. Hi, Rally Monkey. Yeah, so this stream might be a bit short because we're having some 4th of July stuff in about an hour and a half. But I think that might be enough time to tackle my objective, which is to finish up the URI class that I've been working on for the last 7 broadcasts. The only things left to do, actually, I'm missing one. We need to do IPv6 address validation. We need to do that, and then we need to do what I am considering is saving the best for last, which is generating strings from URIs, which is the complete inverse of everything else we've been doing in the class. And the good thing is that writing a string from a URI is very easy. And just to give a little bit of background, if you haven't seen the other videos, I've been working on a C++ class to parse this kind of thing, which is called a URI, Uniform Resource Identifier. More familiar version of this is a URL that you might put in the address bar of your browser. But you can also think of it as also covering things like path names on your file system and names in a collection and other things as well. So the class's job is to convert between the string form of a URI and the individual elements, which I have listed down here in my notes. So we've done just about all of the process of converting or parsing a string to the elements. And we're going to finish up one obscure part of it where you might have a raw IPv6 address for the host name. We're going to finish that up, and then we're going to do the inverse, which is taking elements of a URI and then generating a string out of it, which is a whole lot easier because we don't have to worry about validation and all that other stuff. So let's get started. Just like in the other videos, for this component, I've been using test-driven development. So I have a test suite I've been building up, and whenever I'm adding a new feature, I am adding a test first, making sure the test fails because the feature's not there, then adding the feature, which hopefully makes the test pass, and then reserve some time at the end to go clean up my code because I have a tendency to write code quickly but not cleanly. And going back and cleaning up code is a lot of the times called refactoring. So if you see the word refactoring, that's what I'm doing. I'm not adding any new code or fixing anything. I'm just cleaning it up. Hey, not Zane. Hey, what's auto? Yeah. Someone was teasing me last night that I have it in my frequently asked questions. I really shouldn't put that there until people have asked me a lot about it. I am using gtest, and actually not sure what catch is. I'll have to look that up. Been using gtest a lot. I really like it. And you might recognize gtest in the form of this output. And you'll see that in just a moment. I'm going to go switch over to my unit tests now. You might recognize this as the sort of things that you have in gtest. Your test macro, which defines a test, and the asserts to do the actual checking. Yeah, thank you very much. That justifies it putting the frequently asked questions. I think I'm going to go back and improve the frequently asked questions, remove the ones that aren't frequently asked yet, maybe put a placeholder saying, people don't ask me enough questions, so it's going to be empty for a while. But I do get a lot of general questions about some of the syntax that's in the newer C++. So that's why I thought, I guess I kind of hoped that it would be asked a lot, and then I wouldn't have to address it if people read the frequently asked questions. I don't know. I'm new at this. This is only my 7th or 8th broadcast, so please excuse my noobishness. So let's see. Let's get on track. My goal is to add IPv6 address validation and then generating strings for URIs, and that will complete this class, which I've been doing for the last 8 broadcasts, and we can move on. So new feature. Begin by running the test. And we'll say IPv6 address. And just to save some time, By the way, if you see that, that means my dog is barking in the background, and I'm trying to mute it to avoid you hearing a lot of barking in your speakers. You check on any stream that's English and not web? All right. So yeah, to save time, I'm going to copy the form of a previous test. This one's a little long, but I'll just copy it because I have some useful constructs here that I like repeating. This construct I'm copying here is where we have a lot of different potential test vectors we want to check, and then I can have the actual testing code pretty concise. So we want to have a test of the form, what are we going to call it? What have I been calling it previously? Let me expand all the things. I'm just trying to make sure I pick a name that's consistent with other tests. URI string, there we go. So we have a URI string, and then we're going to have expected host. And also, I want to sort of mix, in this test, mix some valid and invalid addresses. So we'll say is valid. And let's clear our vectors, and we'll keep one as a template here. Okay, let's pick one with a valid IPv6 address. And actually, you know what I'm going to do? I'm not that comfortable with IPv6 addresses yet, so I'm going to go look up IPv6 address again on Wikipedia so I can have that handy off to the side here. They have a lot of examples in here about how you can write them. Okay. Cool. So one valid IPv6 address would be something like this. Correct. That's an address block. Let me expand that a little bit. Loopback address. Okay, that's a good one. Does it always have a /128? I didn't think you have that in the actual address. Ah. So ::: is a valid address. Oh, but it's a route address. A host address would have a 1 at the end. Okay. And really what we want to get out of it is just this part. And I had that in the wrong place, so let's fix that. So that's a valid address. Let's put in a few more valid addresses of different kinds. Okay, here's one. I'm going to just take that, put it here. Here's one where we want to have like a real IP address, but it's an IPv4 address that's being imported in. Don't think you need the subnet for URLs. Right, the slash part? Okay. I think you're right. Let's see. Yeah, some of these other ones. I'm actually not liking this list so much. Well, here's a good one. Oh, I forgot to change that. So these are all valid, and then we'll have some invalid ones. Just so that I don't really need to group them together, but it'll help me to keep my mind in order. So let's pick some invalid ones. So I'll just break some of them at random that were valid. It's interesting how Visual Studio can see that I've broken it. That'll actually help. And in this one, I can simply just add another section and it's not valid anymore. For when these particular cases are invalid, we're not going to bother getting the expected host because we know we expect it to be invalid anyway. How about when it's utterly empty? That's invalid. And then a single colon. And then how about a v but without a dot? because there was provision. Oh, I should open that again. There's the URI RFC. Oh, actually, I have a better copy of this in my VS Code. The syntax rules. So the syntax rules, IP literal. Oh, I already have test cases for invalid and valid IPv features. So I don't need to, I really would just want to make validation rules for these. Okay, I think I will take this one and make it valid, and then make it invalid there instead. Let's play around with that a little bit. We'll make one where it's 256. So that's one too many. And how about one where it just has an extra bit of junk, or just how about not enough? One that's not enough. Maybe one with a dot, but still not enough. Okay. That's probably good enough for now. So the form of our loop will be, we are going to parse the URI string. And here it's not always going to be true. So parse result will be a variable we put it into, and now we'll say assert equal, we expect whether is valid. We expect is valid is going to match our parse result. That's what we expect. 2 times double colon is false too. Okay, good idea. I can actually take this guy and make it valid temporarily, and we'll put in some zeros. So 2 ranges of zeros like that. And then the way I understand it, the rules, you can replace those guys. And yeah, Visual Studio is telling me it's not valid. Right? That makes it valid again. Invalid. That's, oh, there, okay, there's another case where it's invalid. So 2 sets of double colons and one where I forgot to put a number at the end. Both of those are invalid. Thanks for the suggestions, by the way, not Zane. Okay, so we want to do a little bit more checking if it is valid. Let's see, this is not good anymore. Right, okay. And I'm going to just proactively shift out index. That's if the test fails, it'll tell us which index in this list caused a failure. Right, so we want to assert, what we expect is that the test vector expected host, and the actual is, why do I call it base URI? Oh, that's leftover. We can just simplify that a bit. Okay, we expect URI.getHost to match the expected host. All right, so this should build, but it's hopefully going to fail. Running our unit tests, it fails. Okay, so that's a good question. Should the host have the special brackets? I'm going to say no. I think those brackets are only in the URI syntax to how do you say this? To signal that it should be parsed as an IPv6 or IPv future. But once you parse it, kind of want to get rid of those. So let's fix that part first. Let's find the place where we're parsing the host. Parse authority, I think it is. Somewhere in here, yeah. So parse authority is doing various things. I have a comment here to explain it. We have to correctly split up and validate the URI substring containing the host and potentially a port number. And the host can be of various different syntaxes. So we first start at the first character. If it's a bracket, we're going to see that it's an IP literal, otherwise it's not. In the case where it's not, we do a bunch of handling of percent encoded characters. If it is an IP literal, if the next character is a V, it's a future IPv standard or IP standard. If it's not a V, it's an IPv6 address. So here's where we kind of want to focus. Actually, stepping a little bit back, I think right here where we're pushing this bracket in, we don't want to do that. And now I want to look to see where we push in the last bracket. Okay, right here. So we only want to push back a character into our output if it's not a bracket. That should fix the part of our test failing because of the brackets. Okay, good. So we got down to index 3 in our list, which is the first invalid. Okay, so all the valid addresses are parsing perfectly. The invalid ones are coming up as valid, which is what I expected because we don't have any validation. So here's where it gets a little bit tricky. And mostly because I'm not as familiar with IPv6 addresses. These rules sort of helped, but I found it was still hard to understand. What really helped me was the Wikipedia article where they talk about that there are a certain number of groups of up to 4 hex digits. Right, so it's 128 bits total. I'm looking for where they say the exact number of groups. Did they say that earlier? Huh. Whoops. Didn't mean to do that. Eight groups. So we can have up to 8 groups. And then, like we were mentioning before, you're allowed to collapse zeros together by 2 consecutive colons, but only do that. You can only do that once. So we're going to expect up to 8 groups, no more, no less, or yeah, no more, no less, except for a double colon stands for as many sequential zeros as you need to fill it up to 8 groups. So I'm thinking that the best way to implement this would be to keep reading groups, and at the end, count the number of groups we had, and we'll have a flag for if we encountered a double colon. We'll use that flag if we run into a second double colon, we fail it right away. And at the end, we'll use it to see if the number of groups we parsed is less than 8, we're still good. If it's more than 8, or if it's 8 or more and we had a double colon, I think that, yeah, that's a problem. It'll be too many groups. Basically, a double colon stands for at least one group, right? So if we had 7, it's okay, but if we had 8, it's only okay if we don't have a double colon. All right, so let's codify that. We'll do that at this point, after we do the garbage check. And I'm going to be a little bit proactive. My habit would be to just type the code in here. And then I know later I'm going to want to refactor it out. So we'll just proactively make a function for this. So if not validate IPv6 address, it's always going to, well, hold on. Let's try to make it reusable by just giving it the host string. Then we can make it a free function. And here we're going to just bail out if it fails. Stream is on low latency. Yes, I hope it looks good. I was getting some complaints last couple of days about 2 things. There's a lot of buffering, and I'm not used to interacting with chat for a large buffer, so hopefully this is better. Could you also expand the double colons to the full range and then count groups? Full range as in let it expand up to 8? I guess so. I was thinking more that you end up needing 8 groups. So we would count up, and if we're not at 8, we'll see if there's a double colon. Maybe I'm thinking too far ahead. So your suggestion is probably good, and I'll probably realize that when I get to that. Sorry, dog barking. We'll probably get to that thing when we actually write the code. So I have it called here. Let's actually make that. I like to put free functions at first in an anonymous namespace in the same module, and then as I need to promote them to their own module, promote them up to their own library. that kind of progression. So we'll put it here. It's as good a spot as any, as a free function, as in it doesn't have any side effects or state after it returns. And we'll call it something short, like, well, I guess address is short enough. First document. This function checks to make sure the given address is a valid IPv6 address. Valid IPv6 address according to the rules in RFC, because there might be routing rules that might be considered valid, but not for the specific RFC. Just throwing ideas out here. Most of the times, they're not that. Well, I'm gonna assume ideas are good until proven otherwise. How about that? I'll be optimistic. Let's see, address. This is the IPv6 address to validate. And then my somewhat generic and boring response is an indication of whether or not the given address is valid. Address is returned. Okay. So let's count groups. We know we're going to count groups, so num groups started at 0, and we'll have a flag. Double, colon, encountered. And we don't encounter it yet. And this may or may not be good, but one of my favorite things to do for this kind of problem is to make a state machine. So, and we're going to start with just simple integer or number states. So we'll start at 0, and then we're just going to loop for all the characters, or auto, which will be character. This is why sometimes people ask me about auto. IntelliSense tells me it's char, which is good enough for me. All right, so for every character in the address, switch on the state, right? Later I might add names for these states, but we'll see. So state 0 is, I think, where we're not in a group. Not in a group yet. Because we don't want, if there's an initial colon, I believe it's okay as long as it's a double colon. But if it's just a single colon, we're in trouble, right? It's not valid. So if it's gonna, the valid things are gonna be either a colon or if, and here's where I want to reuse the character class set I had before. I think I called it ASCII or hexdig. There we go. If hexdig contains C, else it's something else, and here we just bail. And I'm thinking I'm just going to define my states before I fill in the code for them. State 1 is where we're not in a group yet, encountered a colon, encountered 1 colons. And I forgot to put a break on the previous line. And there, it had better be another colon, otherwise it's invalid, right? And here's where we don't want to run into 2 double colons. That's also bad. Otherwise we just ran into 1 and we're going to return, actually we're not going to return to state 0. It must be a hex digit, so that's what our state 2 is going to be. State 2 will be expect a hex digit. And I should count the number of hex digits because we can accept between 1 and 4 of them. Yeah, so number of groups, number of digits. Right, so we expect a hex digit in state 2. So this is the valid case. Actually, we expect a hex digit, right? So it better be 1, otherwise we're going to fail. If we do encounter 1, we're going to count it. But after counting it, if it's greater than 4, it's bad. And I think I need another state. Well, actually, I don't know. Let's fill in some of the code back here. So if we're not in a group yet, and we hit a colon, we're going to state 2, right? Or state 1. We're not in a group yet, but we encountered a colon. If we get a hex digit, then we'll count it, and then we're going to go to state 2. Actually, it's expect. Okay, here's where it's a little bit different. Here, we might have a single hex digit, so we need a somewhat special or a different case where you expect either a hex digit or a colon. And a thought just occurred to me that we might have to be careful about when we reach the end of the string if we're in the middle of something, like if we are in state, what is it? If we're in state 1 and we reach the end of the string, it's bad. Let me jot that in there right now. If state equals 1, it's bad. Trailing colon. Trailing single colon. We might turn that into a tail call, which would be something like return state not equal to 1. Might do that. All right, back to what I was doing up here. Right, state 3. Yeah, so here it could be either. So if it's a colon, else it could be one of these. Oh, what happened there? That should have been inside the if. It's fighting me. There we go. We don't want to stay in state 2, though. After we get 1 digit, we're going to go to state 3. If we expect a hex digit or a colon, right? A colon means that we reach the end of the group, so num digits goes back to 0, and we count a group, right? Okay. Right, this is not gonna be a tail call because we need to validate the number of groups. First of all, if a double colon was encountered, it seems to me that we can just say it's valid as long as the number of groups is less than or equal to 7. Otherwise, it has to be exactly 8. Because a double colon represents 1 or more groups of 0. So basically it fills up to 8. So that can't be a tail call anymore. Alright, that's what I thought. Maybe what I was saying here before I should put in as a comment. A double colon matches 1 or more groups of 0. Okay. Did I miss any code up here? I don't know, but you know what I'm going to do? I'm just going to run my unit test to help tell me if I missed anything. It failed, but why did it fail? Okay, I don't know. So let me review this a little bit more, because maybe I'll just spot it. Not in a group yet. If we get a digit, we're in state 3. Oh, it's a... No, that's correct. I could make a special state when we get to exactly 4 digits, we have to expect a colon, but this sort of encapsulates that condition already. Okay, I'm not seeing it, so what I'm going to do is I'm just going to run step through in the debugger. Hold on. Let's find the test. IPv6 address. I could have typed that. What's hexdig? A global? What it is, I'll show you. It's a global constant character set, which is a class I wrote. It's basically an encapsulated standard library set of char, but it has a method called contains where you can see if a character is within any of the sets. And this right here, declaration, is a composite set, so it's 3 different sets: 0 through 9, A through F, capital A through F, lower. And we're using, I just lost my place. We're just using it to see if that character is a hex digit. Yeah, range check, exactly. You got it. All right, so set up the debugger. We failed on the second one, which actually means this one passed, which is great. This one failed, though. Oh, I know why. I forgot that you can have a trailing IPv4 address. In that case, I think it occupies the last 2 groups, so it counts as 2. So you can have up to 6 if you have that. And that's a trailer, right? Okay, so that would be if you encountered some digits and then you encounter a dot. So let's catch that. So it'll be when you have encountered a digit, which I think is state 3. Okay, so either a hex digit. Let's be careful here, because if we run into A through F, we know it's not an IPv4 address. So how can we get into state 3? Various ways. I'm just thinking. Okay, yeah, let's just be very careful. So I think I have a digit class. Let me make sure. 0 through 9, that's exactly what I want. Although I need to check for numbers that are greater than 255. Those are not valid IPv4 octets. Best way to check for that, I think, is to just capture them. Well, how does the standard do it? I think the standard actually does it in a strange way. Right, so it says it's either a single digit, it's a 1 to 9 followed by a digit. So this is where it gets a little gross. I'd rather just scan them into another string and then convert it to an integer and see if it's greater than 255 or not. Let's do that. So we'll have a buffer for octet buffer. All right, so we'll make another state for this where it's potentially an IPv4 address. Hold on. Back to this window. I'm just saying, can you have it just be an IPv4 address? You can, as long as you have a colon or 6 groups. Well, that'll get caught in the end because it won't add up to 8. So I'm not going to worry about. I was thinking about checking to see if the number of groups is a certain number before you hit a dot. But I don't think we need to. So case 4 is like case 3, only we're not sure if it's an IPv4 address. Expect either a hex digit dot or colon. And we're going to have to be prepared to upgrade to it definitely not being an IPv4 address. So we still want to differentiate between a digit and a hex digit. If you encounter a dot, can't you send the remaining address to an IPv4 check? I guess I could, but I don't have an IPv4 check. But you just made me think, eventually I probably will, because I'll be refactoring this. Problem is we're into the first octet by the time we see the dot, and I'll have to back up. Thinking, can I just remember where the first potential IPv4 character was? I guess I could, because we'll be either not in a group yet, or it will be after a colon. Encountered 1 colon, it's not a colon. Oh, hold on. Okay, that's not in a group yet, so I forgot to move to another state here, didn't I? I don't have a state for we expect a heck. Oh, I do. It's state 2. Now I'm getting confused. Maybe I need to start naming these cases. No, case 2 is correct. So I could at case 2 and also in case 0 in one of these places just record where that character was. I actually kind of like that idea, so let's do that. So we will just record potential IPv4 address start. And yeah, it'll be here. Oh, I need to start tracking our position in the string. That's easy enough if I just do this. After the switch, I'll just increment position. There. Oh, actually, no. It's definitely not an IPv4 address if it's there. Only if it starts with a digit or here. Or so yeah, here we can bail out early. We know it has to be an IPv4 address or it's not valid. So break. Well, hold on. Let's have a flag called IP4 address encountered. Because what we can do, we can just set that flag and break out. If IPv4 address encountered, break out again. I only want to do this if we reach the end of the string. Okay, that's easy enough. I can make it explicit. The position had better be equal to the size of the address, or length of the address. Okay, now if we encounter IPv4 address, 2 things. We're going to want to validate it. Validate IPv4 address. I'll fill in the parameter in a second. And even if it's valid, we want to count that as 2 groups. In other words, 32 bits. Each group is 16 bits. Okay, so the argument for this, it's the substring of the address starting with that marker we set, potential IPv4 address start. So let's set up that function. Yeah, it's a good idea to have this as a separate function for two reasons. I might later want to do the same kind of validation, and also the state machine's rather different. Oh, before I do that, it just occurred to me, we need to fill in this. This is slightly different. If we actually hit a hex digit, we're not in state 3 anymore, or 4 anymore, we're in state 3. And yeah, I was thinking 4 digits in a row, and then a dot will look like an IPv4 address, but then that test down here will catch it. All right. So this is going to look a bit the same. Well, let me copy the whole body here. Why does that not parse? Oh, I missed a parentheses. Okay. It's going to look somewhat the same in structure, only we don't have this part. No double colon. Groups has to be exactly equal to 4. We're going to have similarly if we reach the end, trailing character, I guess. Trailing dot. Just thinking. Oh, hi, Ubi. Welcome back. Yeah, so today I'm doing the last bit of validation for the host element of URI, and then we'll move on to generating strings from URIs. This is the last bit where we've validated and parsed every possible kind of piece of a URI. We're just finishing up with what I think is a bit complicated is validating raw IP addresses. And we're down to IPv4 addresses, which hopefully is pretty simple. So we're still counting the number of digits. There's no double colon thing. I don't need that octet buffer either here or here, because we're going with a separate function. We don't need a potential IPv4 address start. Don't need position, don't need that. So not in a group yet. Correct. We don't need this. We expect a digit at this point. Oh, actually I do need that octet buffer, don't I? Octet buffer. Because we're going to funnel digits in there so I can convert it to an integer and make sure it's not out of range. I don't need to count digits either, do I? Don't need to do that. Yeah, actually that's using namespace standard. Some people do that and other people don't. I can't really give an answer why I don't. Not a good answer. It's just something I'm used to doing. So anyone who's watching that doesn't know what we're talking about, if you did something like this, then we don't need all these standard colons. I guess I could say I don't like that as much because this doesn't remind me it's from the standard library. Whereas if I force myself to type those few characters, then it's a stark reminder that it's from the standard library. All right. Once again, if you see that layer pop up, there's some loud noise in the background, and I'm muting it so you guys don't get distracted by it. Let's see. Okay, we don't support hex digits. And we don't really need to tell if we're in a group or not, do we? You want me to show that again? Yeah, that's my dog that barks a lot if anyone knocks on the door. So let's see. We don't need to change states here. This is going to be a much simpler state machine. It's not that we're in a group yet. We're parsing an octet. And this ought to be an else if because we can run into a dot. Oh, hold on. It is a little bit different. It's not in a group yet. It's not in an octet yet. Because if we run into a dot, or if we run into anything else, it's invalid. But if we run in, after the first digit, a dot is okay. So I think that was state 2. Yeah, expect a digit. And we're going to push that back in. Everything else. Oh. Dot is allowed, right? Expect the digit or dot. Yeah, push back works for strings too because it's a container of characters. Push back. Let me bring up the manual. That's an easy enough thing to do, and I can just refer to it. So I use this program called Velocity to hold on to manuals offline. So pushback, if you look at any of the standard containers, it's the same. It's basically appending an element to the end of the thing. Yeah, Velocity is the Windows equivalent or port of dash on the Mac. Yeah. So a dot means we need to validate the octet. Let's make a function for that. If not, validate octet buffer bail. If it's valid, then we're going to clear it, and we're going to go to state 2 again, or state 1 again, or 0. And make this a 1. This needs to go to 1. Resize manually the array. Two things about C++ in school. Depending on when you went to school, it might have been C++ 98, I think, before C++ 11. The other thing is, one weird thing about school is they like to drum into you a lot of the fundamentals that in the real world are kind of, I don't know, silly or inefficient. So you'll end up doing things slightly differently in school than you'll end up doing in the real world. And that's in order for you to learn better. Borland C++ builder. I've never used that. I've mostly been on Microsoft and Linux tools. I don't know how ancient it is. I guess it is. That back in 2000, 1995 or something like that. That's what comes to my mind. All right, so I'm going to make a validate octet, and it's the same kind of thing. Octet string. So it looks like yeah, all right. So same general signature. This function checks to make sure that the given string is a valid rendering of an octet. It has a decimal number, right? Pretty explicit. The given, yep. I'm already anticipating that I'll need to make a frequently asked questions entry about why the hell am I so repetitive between these two? I'll describe that really briefly. One thing I might want to do with this library is run a tool like Doxygen, which generates a nice PDF reference manual for my library. It's going to parse all these comments, the ones that start with / and then 2 asterisks. And it's going to pull these 3 things into potentially separate areas of the document this is giving a summary of the method, and this is giving the return value of it. Depending on what part of the manual you're reading, you might only see the summary or you might only see the return value. Either way, I kind of want it to be very plain what the point is of this kind of function, which is that it's returning something or it's checking something. And so I'm going to be a little bit repetitive between the return value meaning and the overall function meaning. So that's why. Okay, so validate octet. I'm thinking about being a little bit non-wheel reinvention-ish, if that's even a term, and using a library function. And using an old school library function from string.h. Or is it? No, it's standard IO. And it's scanf. So if scanf octet string as a C string, it's going to be. Will this work? We'll test this in our unit test. The pattern for an unsigned integer of 8 bits. And we're going to put it in, I don't know, Scratch. Or how about octet? Give it a legitimate name. That had better be equal to 1. If it's not equal to 1, it fails. And then even if it parses correctly, let's give it a storage here. It can't be greater than 255, right? Well, less than or equal to 255. This feels better. Less than 250. No, hold on. We're comparing 8-bit. Wait, actually, isn't that obvious? That's obvious, right? So I can just say return. Oh, hold on. I'm thinking faster than I'm talking. One problem with scanf, right, is that if you had something like 255.5, or let's say 255x would be a better example, it'll say, sure, I scanned that, and it won't tell you that it had garbage at the end. Okay, maybe scanf is not the way to go. All right, let's reinvent the wheel. It's not that hard. We'll simply have something bigger than a u and date. Just make it an int. Start at 0, and then we'll just loop for every character. And it's going to be if it's a digit or we fail. Okay, I'll leave this check in here. Now we're going to shift, or really multiply by 10 what we had in there, and then add the character converted into a number. I think that's what we want. So validate octet should be done. Okay, I wasn't done with IPv4 address. Right, so let's see what we need to. This is all copy pasted from before, so it's all bad. If it's a dot, if it's a digit. We don't even need a state 3. Oh, I forgot to count number of groups. Guess we can have an early return if it goes past 4. If number of groups, if we get a dot after 4 groups, we should just bail. And we can do that even before we validate the octet. I don't think I need these other states. I don't need this, and I don't need that. And I don't need any of this stuff either. But I do need to validate the octet buffer if it's not empty for the trailing octet. If not octet buffer empty, if not validate octet buffer, return false. There we go. Hopefully this just works and I can say, hey, my unit tests have told me they work, let's move on. Of course it doesn't work, so the index 1 of our test is still not validating. Well, let's see why. It's probably in the part where we're detecting the potential IPv4 address, so let me see that. We ought to get to this part. Oh, hold on, we didn't even get to that part, so something happened earlier than that. So let's try to catch where we encounter the dot. Okay, didn't run into that either. And look at that test case again. There's a colon. Not exactly sure what is happening, so let's see it from the beginning. So index 1. Oh, we could skip this stuff. Oh, I could just hit. I've already refactored this. This used to look really messy. Now it actually fits in one page, which is awesome. After we refactored. Refactoring is the way to go. After you write code, you need to go back and refactor and clean it up. It was in this parsing the authority, right? Oh, parts authority. That's where we really. Yeah, that's where we really care about it. Sorry, Ubi, I missed the joke. Oh, your coworker told you that your code was messy? Is that what you're saying? I have a really bad habit of writing messy code. And actually one of the things that you guys are really helping me out with is whenever it does get messy and I don't notice, people will say that, isn't that code messy? And I'll stop and say, yeah, you're right. Did I compare the octet with 255 because you're off by 65K or so? Well, octet is a number from 0 to 255, right? Unless I'm not understanding. Okay, IPv literal. It's not a V, so it's an IPv6 address. Okay, so we can really skip until... Yeah, my brain's not working so well today. We could have just put the breakpoint here. That's what is going wrong for us. So the character is the initial colon. So we get a state 1. Double colon encountered, so we're in state 2. And we expect, okay, the character is a hex digit. So now we expect more hex digits or a colon. Right, so there's a few more. Now we run to that colon and we count that group. And where are we in that string again? Where's the string? Okay, so we're in the first character of the IPv4 address. Okay, I think I see the problem. This path I didn't expect. We need to handle that if it's a digit. I think. Oh, no, I'm wrong. I think we returned to the wrong state when we hit the end. Yeah, so we went to the wrong state. It might be... No. Difference between 2 and 3 is a colon is allowed. 3, though... Yeah. Do recursion version of it. Recursion function? Recursive version? If only you could have IP addresses inside of IP addresses, then it would recurse, right? Let's see. to help me see, I'm going to run that again. Oh, did I change something? What did I change? Oh yeah, I thought I was needing to fix something and I wasn't. Going back to debugging this. It hangs out in state 3 for collecting that first group. What? Hold on. Oh, I didn't transition out of state 3. That's the problem. We run into a colon in state 3. We got to move to a different state. And that was that we have to expect a digit. Oh, recurse the characters? I call it iterating, right? We're iterating through the characters. I hope I'm understanding what you're saying. I guess you could make it recursive. You could just say parse the first character and then call it again for the rest. But that couldn't really have a state machine unless I passed the state into the recursive call. Oh, that would be really fun and ugly. At least the way I would do it. I'm sure someone else could write it better, but I don't know about myself. Okay, let's see what this does. I want to make sure that it's doing the right thing after it gets that group. Okay, so we should go back to state 2. The digits that 1. Okay, here. So this is good. So now we've recognized that this might be the potential start of an IPv4 address. So we go to state 4. We hit the dot and we say we encounter an IPv4 address. So we break out. So now we are validating the IPv4 address. All right, we're actually looking really good now. I missed a little bit of chat. It's fine. As it is fine, you pass the state machine to the next call. At any given point, you could test specific case without having to go through all the characters. Yeah, I guess I've been burned in the past by recursion. So I kind of avoid it. But to each his own, right? The field of programming is really wide and there are lots of ways to solve problems. Is maybe one of the reasons why a lot of people like to do it. There's a little bit of creativity in it. So recursion is not my cup of tea usually. All right, I think this IPv4 address validation is simple enough that I'm confident it will work. Okay, the first octet was 1, it's valid. I need to have an example with more than 1 digit. Oh, no, I do, don't I? Actually, I think this will work. We'll let it go all the way down to here. The last one had a 4. Validate that last one. We had... Ooh. Yeah, we didn't count it, did we? Count it. Fair enough, C++ is not that common to do recursion, so... I wouldn't say that. I've seen people do a lot of recursion in C++. I've actually seen it more in school and lessons and stuff than I've seen it in the real world. I'm actually thinking this will pass our tests a little bit more, so I'm going to run it again. And it did pass that specific case, but it got to index 2, which is this long one, without any double colon in it. So something's wrong with this one. So let's see what's going on with that one. All right. Here's that somewhat scary address. I'm actually going to guess that we ran into one of these trailing tests. Yeah, that's what it was. So hold on, that said false, right? Okay, double colon countered. Ah, we counted only 7 groups. Right, we're probably in the state where we're state 4 where we're in a group. So it's like the last bug I fixed. If we're in one of these groups where we've already parsed a hex digit, then we need to count that last trailing group. I think it's just state 4 or 2. What's the difference between 2 and 4? Expect a hex digit, dot, or colon. I really should have said, why do we expect a hex digit here? And I'm already thinking I need to give these names so it's more clear. We'll do that when we refactor. So let's see. Okay, we expect a hex digit because we just got a colon. In fact, we got a double colon. So it has to be a digit, but we're not in a group yet. Won't we want to catch it here too? No, a double colon at the end is allowed. It's only state 4, so if state equals 4, we have to count the last group. Count trailing group. Groups aren't required to have 4 digits. They can be 3, 2, or 1. Added with zeros. Yeah, that's right. I'm only doing validation though. I'm not actually returning the groups or decoding them. So I get to cheat a little bit. I don't have to actually count them. Well, I do count them just to make sure there's not more than 4. I'm counting, yeah, no more than 4, and they have to be hex digits. That's all I care about right now. Let's see if that works. Oh, we actually passed that unit test, and I broke a different one. I see. I changed our let me back up. Because this is a little point of instruction, I guess, on test-driven development. When you build up your test suite in test-driven development, your test suite becomes the documentation of your requirements of your class. So what happened here was I had a test that was passing before, but is now failing. That means either the requirement was wrong, or I changed the requirement, or I broke something in the code. In this case, I think the requirement was wrong. It was expecting the host to have these brackets around it. And then earlier in this stream, I decided that was wrong, that those brackets are only there to delimit it in the context of a URI, but once it's been parsed into just the element host, we really shouldn't see the brackets anymore. That test on line 365 is a broken requirement or invalid requirement, so let's fix it. So here we go. The requirement really should be no brackets on either end. I know it's going to fail because I saw it left in the end bracket, and I think I know why. But let's verify that it's that end bracket. I handled the end bracket for IPv6 addresses, but not IPv future addresses. Here we're still pushing it back in. We don't want to push it back in if it's an end bracket. Actually, when we're still parsing the IP standard number, we can't have the end anyway. It's in the body here. Right, so it's pushing it back regardless. We only want to push it back if it's not an end bracket. Something like that. Actually, it's just going to bail, so I can put it in an else. So now we should be conforming to our updated and fixed requirement. Check it out. We passed all our unit tests. I love to see that at the end. Now, to get extra confidence, we could invent some more test vectors. And this is where some people kind of enjoy things because they like to try to break their code or other people's code. Maybe you guys can come up with some test vectors to try to break my code. No pressure. I'll try to think of some right now. Yeah, exactly. We're going to add more edge cases. So, I had 256. I know this ought to work because it should throw it out, but just negative number. How about a space? That won't even get to IPv4. It should throw it out earlier than that. What else? How about some trailing junk? IPv address with only one missing bracket. That's a good idea. We'll just forget the bracket. Probably should do it both, right? Oh, these need to be otherwise valid. We don't want it to fail for the wrong reason. To make sure, yeah. So Visual Studio is actually helping me. It starts to highlight it if it's valid. So I was going to cheese that one by chopping that one off. Let's see, those should all be invalid. Oh, something's broken. So index 12. This one it thought was valid. Okay, so that was good. We found an edge case. I think I know what happened. I think it fell out of the end of this and didn't see that it was not in a terminating state. Yeah, so really should define what our terminating states are. I think not IP literal is it can terminate in that state fine. And garbage check and port. These are the only states we can end in. So let's just copy these states, and if it's not in any of these states, it's not. It ended too early, really. If what did I call the variable? Post parsing state. Post parsing state is there are only three that that are allowed. So I'll say if it's not any of those three. If it's not this one, and it's not garbage checker port, then we bail and we'll say truncated or ended early. Let's make sure that, okay, it passed that one and failed something else. 364. This one. Oh, okay. So here's one where the host is completely empty string, right? So authority marker is // and then the slash is the path, the beginning of the path. Is that allowed? Can you have a completely empty path? I mean authority? Let's check. Oh, better would be my notebook for the syntax here. Yeah, it could be a registered name which is completely empty. So I think I know where that ends up. We had that state called first character. If we fall straight through and we're still in, if we end in first state character, it means there were no characters. So we want to allow that. That's a completely empty registered name. Okay, we're passing again. Okay, thank you, Not Zane. Thank you for viewing. And thank you again for that address. You actually caught a bug. Bravo. So some more corner cases. How about we put in a hex digit? Like A. And another one where it's not the first one, but the next one. Oops. Wrong window. Still passing, so looking good. I'm just looking at the time, and I think I want to move on. We can come back here later if we want to add more corner cases. It's a good opportunity to go check this code in. All right, so there are actually a couple things we did. This one's important here. This is an actual requirement fix. Fix bad requirement. After parsing a URI, we don't want the square brackets to remain in the host element, because those were only there to delimit it in the context of a URI string. Okay, the other concern that we addressed was IPv6 parsing, or validation really. Validate IPv6 addresses. So that was a couple different pieces, right? And that's a bug fix. I'll check that in separately. That's another bug fix. It's this part specifically we added for this concern. So really, let's invert this. So I'll just stage what's concerned with adding the validation. Just these 3 lines, because all those other ones were bug fixes. In this huge hunk, which is the body. Yeah. Validate octet, validate IPv4 and IPv6 addresses. And I have a feeling we're going to promote those up at some point to their own library. So add validate IPv6 address. Add validate IPv4 address. Since an IPv6 address is allowed to contain an IPv4 address for compatibility. Is that the right word? Compatibility. And then we added validate octet used by validate IPv4 address. That was the main concern that we were concerned with today. And then we have these various bug fixes. So let's handle the bracket thing first. That was one piece of it. This is another piece. That was another piece. So fix bug in parsing out IPv6 and IPv future addresses. Don't include the square brackets in the parsed out host string. They are only there for delimiting them inside of an overall URI string. Okay, and the last bug fix was this trailing thing that Not Sane helped me find. Fix bug in truncated host element. In truncated host elements. For example, where this square bracket at the end is missing. Handle truncated host element by checking the state we end up in after the entire string is parsed. Only some of the states are valid. Not the right term to call it a valid termination state, but only some of the states. A better way to say this would be many states no, that isn't right either. I'm trying to think of a nice way to put it. some states represent internal elements of a host name or address. And so if we're still in those states and run out of input characters, the input string was cut off early. I think that's good enough. Okay, so that with that I can go back to my notebook, say we did IPv6 address validation. The next thing I want to do is generating strings from URIs, and a final check to make sure nothing stands out as needing refactoring. Actually, I already know of something we want to refactor. I'll leave that for next stream, which I think will be later today, and that is the big state machine we just added. I kind of want to give like this one has names for the states. The one we just added up here does not. For IPv6, this one doesn't have names, and we have 5 states, and that sort of crosses the threshold for me of needing to name them to understand what they mean. Excuse me. So, generating strings from URIs. I think what I'll do for this stream, since I need to end in a little bit to take a break, is I will get started on this but not finish it. We'll do part of it. Actually, probably what I'll do is set up a test and then partially implement it, and then I'll complete the implementation later today. So let's start off with the test. We'll kind of copy the last test we did. I'm kind of liking this pattern. So here, what do we want to call it? Generate. So we want to be the inverse of parse from string. So generate string. Generate parse from string, generate string. I guess it's as good as any. Right, so let me think about how I would put it into a test vector. Probably something like this scheme. Host. Let's just keep it simple. We'll just have query for now, and then we'll add other things to this later. I just want to get something complete that, or not complete, something partially complete that passes, and then we'll fix our requirement later. So the output, it'll be what is the URI string. So we don't have to concern ourselves with validation anymore, which is a great relief. We're just constructing URIs now out of their pieces. So HTTP www.example.com and then foobar. What that should generate is http://example.com !foobar. We'll just start off with one test vector for now. So the general rule will be we'll be setting the scheme and then setting the host and query. And there's no failure, so we could just call generate string. Well, that actual, we'll call this one expected. And then we simply assert that the expected is equal to the actual. All right, so our test is complete. The next step is to get it to compile, and that in order to do that, we need to declare the methods that we're adding. Set scheme is first. They're not constant. Host and query. I'll document them in a second. All right, and then generate string. That is constant. And this needs to have the test vector in front. So now we'll compile and not link. So again, step-by-step process in test-driven development. And I will get back to documenting that in a second. Maybe more than a second, not too long. Okay, here we are giving bodies to the class methods we just declared. And we'll do the trivial ones first. These are extremely easy because we just say to store them. And then the generating string is the fun part. So let me think about this. Let's use string stream. String stream. That is in stream, I think. Right, so let's do the naive implementation, and it won't be correct, but we'll fix it when we add test vectors later. So we'll just push out the scheme, followed by the colon, then push out the host. It's not just colon, it's colon. Well, if it's got an authority, it belongs here. I'm just thinking ahead because these two lines of code are concerned about different things. This one's just a scheme part and its delimiter, and this is authority and its delimiter. And then finally the query. And then return buffered as string. Now that should get our test to link and actually pass. I kind of skipped a step. I should have just returned empty string and saw that let's do that. Let's pretend I didn't write that yet. And we'll just return empty string and make sure that, we want to make sure that our test initially fails. Otherwise it could be that the test passed because it really didn't test anything. Okay, so the test passed, it expected something and didn't get the right thing. So then the last step is you fix the test by implementing the method. Test passes. So we know this isn't correct because let's break it right away. Very easy to break. And that is you don't have any scheme. And let's say you still have a host. And no query. Well, let's break it one step at a time. This should just be /example.com bar, right? Let me make sure I'm doing my rules correctly. So in this case, it's a relative reference. Starting with // means it has an authority. The path can be empty, which it is. All right, so it's valid. I guess Visual Studio only shows blue links if they're obviously web links. This is obviously not because it's no scheme. It's a relative reference. So that's what we expect, but the test is going to fail. It fails. It fails because it put a colon in front. And I think the best fix for that is really only to do this step if the scheme is not empty. Right? Right. So let's break it again. This time we won't include a query, and we expect it to just end like that. Broken because it put a question mark at the end. So same kind of thing, only if the query is not empty. Shifting it out. At this point, I think you guys can see where I'm going with it. We're building it up piece by piece. If it's completely empty, we want it to be completely empty, right? Technically, it's a valid URI. It's not very useful. And we get slash slash, right? So far, so good. So let's see what else. Other combinations of this. A query but no authority, I guess. So it should just be that. And these are all going to pass hopefully, so I'm not going to test them quite yet, just to save time. Let's try that one where it has a scheme and query but no host. And finally, one that has a scheme only. These should all pass. All right, so I know how we can break it. We can make an IPv6 address. Oh, hold on. I don't want to make the test incorrect. For an IPv6 address, we needed to add the delimiters. It's probably not going to do that, right? Didn't do it. So I have what I think is a clever way to fix this without having, because the first question is, how do you know when to put the bracket in, right? And your second thought might be, well, you need to know if the host is an IPv6 address. Well, how do you know if it is? What if you try to validate it? So first, let's break this up. We know we need an authority marker. What we don't know is if we need to put the brackets in it. So a way to, what I think is a cool way to do this is we can reuse, it wasn't an impl, we can reuse our validate with our own state. If it validates as an IPv6 address, then we're going to, well, basically the same thing but with brackets around it, right? Oh, I needed to put that into an else because it printed it twice. Cool, huh? So we're reusing some of the logic we made for parsing. In this case, it's for generating because we know we just need to know if the delimiters are needed or not. All right, so something that's a raw IP address should not have the brackets around it. I think that ought to work because the way our state machine is written, this isn't an IPv6 address because there's no colons in front. Still passes. Great. And then just for kicks, we'll combine these two. Oh, hold on. That's allowed, right? Or do we need to have a group in front? Yeah, because this rule is satisfied, right? 0 or more. Yeah, so it's good. I'm not that knowledgeable in IPv6, so. All right, so it still passes. And then I'm just thinking, can we do more with just these things? So what we're missing, obviously, are things like the fragment, port number, user info. This is going to get a little messy. So one way I can clean it up, just since it's easy to do right now, would be to add some white space to make it a little easier to read. Just a little bit more. Shouldn't take too much more, right? Thank you for bearing with me on this. Almost done. All right. That's still working. I didn't break it. We should probably check this in. Oh. Good point to check it in. So we're adding basic URI string generation at this point. Oh, I forgot to comment that. Okay. Commenting speed run. We only have to take our time on the first one, and then I can do quick copy paste for the rest. This method sets the scheme element of the URI. This is the scheme to set for the URI. Okay, and here's where I can hopefully do it faster for the rest, because I'm copy pasting, and that's slightly different. So it needs its own comment. This is host, and this is query. All right, so this one needs its own separate comment. This method constructs and returns the string rendering of the URI according to the rules and then we'll just quote the RFC again, because why not? Are no arguments, we're just returning the string rendering of the URI is returned. All right. Make sure I didn't break anything, and I'll check that in. I think I'm going to be wrapping up the stream soon because there's activity behind me. People are setting up the grill and all that. So taking a break for a couple hours and come back into it. So we're going to review. So to wrap this up, I'm going to be checking this in, and I'll do a short recap and talk about what I'll be doing next time, which will be in a couple hours, hopefully. So here, let's stage all these changes. We add generate string incomplete. So add ability to generate URI strings out of scheme, host, and query elements. This does not yet support user info, port, or fragment elements. We'll be doing that next time. It'll be really quick, and after that, we'll be refactoring, and we'll be wrapping up this class and moving on to something else, I think. All right. Is this all we really need to say? I didn't fix anything. I added add methods to set scheme, host, and query elements. All right. Commit that, and I'm gonna go ahead and push that upstream. I put my code in Bitbucket. I haven't yet made it public. Probably will at some point soon, so that you guys can check it out as well. It's all checked in. Let me review what I got done today. And I'm already noticing I'm not able to do all of a plan, so I need to cut back on what on my ambitious plans and try to match, make sure I get done what I hope to get done. Some notes for this stream. I did try out low latency mode. I hope that worked. And I'd lowered the opacity of the chat overlay, so the little blackish, grayish rectangle in the bottom right showing the chat log. It used to be completely black, and that was distracting to some people. So today I got the IPv6 address validation done. Did some of the generating of the strings, but I didn't get to a couple things. Yeah, I didn't do this. I need to remember to do that next time. And then we're missing user info, port, and fragment. And then I didn't get this final check for refactoring, so that's probably what I'll start the stream off next time, is we'll finish generating strings from URIs with this special case I need to make sure I don't forget. Then do final check and some refactoring, and then I'll be able to wrap up this URI component. And then move on to the next stuff, which I'm kind of keeping together under this plans tab. And by the way, this notebook is publicly viewable. There's a link below for it. In the short term, I'm finishing up URI, and this is the last piece of it. And then I'll be moving on to 2 more components. UTF-8 is for Unicode for international character sets. The more interesting one, I think, is this internet message component. We'll be able to use that to parse and generate requests and responses between our web server and web clients. And as a side benefit, it's also the same format that email is written in. For raw email messages, it uses the same exact format. It's, a sequence of headers and then blank line in the body. So we'll be working on that. And in the medium term, I'm going to bring in another component called system abstractions to handle networking and some other utilities. That should give me all of the baseline stuff that I need to actually start working on the real web server, which is where I think it'll get a little bit more interesting, because as I build up this web server, I'm hoping to make it live so you guys can try to break it or play with it or access it live. Once we have that going, I'm going to be adding WebSockets and dynamic content through plugins to the web server, like libraries that you can link in and start running without restarting the web server. And then where all of this is heading in the long term is 2 different objectives I had in mind. Making my own Twitch bot, because Twitch has a web API. And then I want to ditch WordPress and replace it with my own blog system based on the web server and the plugins I make for it. So under this history tab, I have a log of each time I stream. I'll be putting in a retrospective in a bit off stream. And just before my next stream, which will probably be in a few hours, I'll be making the plan for the next stream. And all of these streams, by the way, are archived in YouTube. I mean, there's a whole lot. I would recommend that if there's something you're interested in, just scan through the titles and look up the video you want to watch. So thank you again for watching. And it'll be later today, a couple hours, I'll be streaming some more. And my schedule isn't really set, but generally right around this time and this month and next, it's going to be mostly in the evenings Pacific time. Today is special since it's a holiday, so I'm streaming during the day. Thank you again, and I will see you in a bit. Thanks for watching.